हेलो गाइस। आज हम लोग स्टार्ट करने वाले हैं फिजिक्स का मोशन इन अ स्ट्रेट लाइन चैप्टर, जो सीबीएसई पैटर्न पे बेस्ड है। जो मैंने सीबीएसई की टेक्स्ट बुक से आपको पढ़ाने की कोशिश की है। अभी हम लोग स्टार्ट करेंगे थ्योरी से। उसके बाद धीरे धीरे हम सीबीएसई के क्वेश्चंस करेंगे, उसके बाद आईआईटी मेंस के क्वेश्चंस करेंगे, राइट। एचसी वर्मा के क्वेश्चंस टेकअप करेंगे। स्टे ट्यून्ड, लेट्स गेट स्टार्टेड विद द वीडियो। गाइस, लेट्स स्टार्ट विद मोशन इन अ स्ट्रेट लाइन. So every time you walk, run, or drive, you experience motion in a straight line, right? So physics gives us tool to describe this motion precisely. Now we come across motion in straight line in various ways, right? So you are walking on the road, you are driving a vehicle on the road, you are driving a bicycle on the road, right? So all these types of motion are called as rectilinear motion. So what is rectilinear motion? Those objects which move along a straight line, right? So the motion is called as rectilinear motion. We also consider a concept of point objects. So why we are taking point objects? Because the size of the object is much smaller than the distance it moves in a reasonable duration of time, right? So your size is very small with respect to the distance it is moving. Okay. So when you don't want to study the causes of motion, you have kinematics. And what do you mean by the motion where you have causes? That will be called as dynamics. So the causes of motion can be force, and there are many type of force. It can be gravitational, it can be frictional, it can be electrostatic, right? So in this chapter we will basically be dealing with kinematics. It means that we will only study the motion and not the causes of motion, okay, and not the causes of motion. So let us understand what is instantaneous velocity, average velocity, and speed. So what is average velocity? It is, let's say you are at point x1 and after time t you are at point x2, right? So you have covered the total distance of x2 minus x1. You were at x1 at time t1 and you came to x2 at time t2. It means the total time taken is t2 minus t1. So this is the average speed. This is the average speed. Okay. So it can also be written as delta x divided by delta t. That is average speed. Now, so let's say this was your x1 at t1 and this was x2 at t2, right? So this is the graph of distance versus time. Okay. Now what we are doing is we will decrease this distance. We will decrease this distance. Okay. So first one is P1, P2 point. Now we are decreasing it to Q1 and Q2. And then finally T1, T2, and at finally this point, that is T0. So this distance will be very small. So delta x will approach to 0. So it will approach very small, very small. It is very small. So delta x is approaching 0. It means that this distance which we have taken is very small, right? So how do we define this very small x? Delta x upon delta t. What we will do, we will make this delta x very small. It means we will put limit, right? What limit we will put? We will decrease the time duration, right? What we are doing here is, so initially it was P1 and P2. You see the time, this is the time. Now we decrease to Q1, Q2. This is the time now. Then T1, T2. So what we are doing is we are decreasing the time, right? We are decreasing the time interval. Basically we are decreasing the time interval. So what we will do here, we will put limit of delta t tends to 0. Okay, we will make this expression when delta t tends to 0, it will approach to 0, not exactly 0, but it will approach to very very fine, 0.00001, like this, even lesser dimension, right? So how do we represent this? This we will represent as dx upon dt. Okay. So whenever you come across such expression, you must understand that the time interval has been reduced at very very lowest margin, right? Lowest interval. The interval is very 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 small, right? So this particular instant when this point object was traveling, at this particular instant when we have decreased the time dt as very very small, this particular event will be considered as an instant, right? Instant means at that particular point of time, okay, that very small time duration. In such instant, we call this dx upon dt as instantaneous velocity. Okay, instantaneous velocity. Why we are referring it as velocity? Because it has magnitude as well as direction. Okay, it has magnitude as well as direction. That is why it is called as instantaneous velocity, right? So this is also called as differential coefficient of x with respect to t, and is called as rate of position with respect to time at that instant. So this is the graphical method. So graphical method for determination of instantaneous velocity is always not a convenient method, right? Why? Because it may lead to error in examining the points, right? It's easier to calculate the value of velocity at different instant, okay, at different instant, if we have the data of position at different instant or exact expression, right? Exact expression of distance with respect to time, right? Then only we will be able to find out what is the instantaneous velocity, right? So let us do an example. Let's say the position of an object moving along x-axis, right? So let us make x-axis. Okay, so this is x-axis, this is y-axis, right? And the position of an object moving along x-axis, it is given by x is equal to a plus bt square. Let's say this is the equation. The values of a and b are given. A equals 8.5 meter and b is equal to 2.5 meter. These are given quantities per second square, right? This time t is measured in seconds. Okay, this is also given. We have to find out velocity at t is equal to 0 and velocity at t is equal to 2 seconds. So how can we find out? So what is velocity? Velocity at t equals 0 and t equals 2 means what do we have to find out? We have to find out instantaneous velocity. We have to find out instantaneous velocity. So how do we find out? V is equal to dx divided by dt. This is the formula for instantaneous velocity. So how do we write the expression? So d of a plus bt square, right? This is the differential upon dt. Okay. So let us calculate. So it will come as the differentiation of constant is 0 and bt square is 2 into bt. How we are getting this? So we are basically getting this d by dx of x to the power n. This is the identity. So it will come as n into x to the power n minus 1. So this is the identity. So here we have put the same identity for t square. So t square, it will be 2 t to the power 2 minus 1, right? So this 2 is coming here, right? So dx upon dt is equal to 2bt. So what is velocity at t is equal to 0? So it will be 0. What is velocity at t is equal to 2? So it will be 2 into b into 2, right? So 4b, what is b? To check the value of b, b is 2.5, right? So 4 into 2.5 is equal to 10 meters per second. So this is the velocity we are getting, 10 meters per second. Now if you are asked to find out the velocity or the average velocity, basically, right? Average velocity from time t is equal to 2 seconds to t is equal to 4 seconds. So 2bt. So this term is for instantaneous velocity. So what we have to find out? Average velocity. So what is average velocity? It is delta x divided by delta t. Okay, so what is delta x? So it will be x at t equals 4 minus x at t is equal to 2 divided by 4 minus 2, right? So x is equal to a plus bt square, right? At t is equal to 4 you have to put minus
a plus bt square at t is equal to 2, you have to put divided by, so what you will get, so a gets cancelled, bt square, right, b common, b by 2 common, and t4 square minus t2 square, right? So what is t4? That is 4 square minus 2 square into b by 2. What is the value of b? The value of b is 2.5. ओके, सो यहाँ से क्या आ गया, 16 माइनस 4 डिवाइडेड बाई 2 इंटू 2.5, so क्या आ गया, 6 इंटू 2.5, that is 15 meters per second. This is the average velocity we are getting. So just note that for uniform motion, velocity is the same as average velocity at all instant. तो अगर यूनिफॉर्म मोशन होगा तो होगा x टाइम. सो यूनिफॉर्म मोशन की वजह से ये जो कर्व यहाँ पहले बन रहा था x और t का, सो ये हर जगह जो है ये स्ट्रेट हो गया, राइट. सो हर इंस्टेंट पे इक्वल टाइम इंटर पे इक्वल डिस्टेंस कवर कर रहा है बॉडी. तो एवरेज वेलोसिटी यूनिफॉर्म वेलोसिटी के, सो एवरेज वेलोसिटी इज इक्वल टू, you can say, instantaneous velocity. Average velocity will be equal to instantaneous velocity, right?
So guys, this is the theory with respect to distance, speed, instantaneous velocity and average velocity. In the next lecture, we will be discussing everything about acceleration and kinematic equation of uniformly accelerated bodies. Okay, so stay tuned. Thank you for watching.